Okay, in the last segment I introduced functional groups, and again you're going to need to practice. Okay, then I'm showing you biomolecules, where you see these functional groups in biomolecules. So we looked at these various carbohydrates and saw that all carbohydrates have alcohol functional groups. Some have aldehydes, some have ketones. Okay, on the next page, well, my drawing didn't come out very well here. I'm guessing that this was what I wanted. That's a benzene. This is an amide. And I think this is aspartame. Okay? I think that this is aspartame. Aspartame is 2 amino acids linked together by an amide, which we call a peptide bond. And so it's what we call a dipeptide, amino acid 1, amino acid 2. Here's our amide, peptide bond, and it actually tastes sweet. Okay? On this one, those are alcohols. These are all carboxylic acids. And what they do is they come together to form 3 esters. And this is what we call a triglyceride. Okay, so when we consume triglycerides, we have these long chains of carbons, and our body has to move backwards to disassemble the triglyceride into 3 fatty acids and this substance, which is called glycerol. And then what we would do is we would take these substances and we would put them through the metabolic pathways, and that's how we get energy out of it. This, I'm pretty sure, was supposed to be cholesterol. Cholesterol is going to have one little OH group over here. Okay? Cholesterol. Okay? So cholesterol is highly, 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 highly nonpolar, and it has this polar N, which explains how it behaves in the body. Okay? Now the last one on my list here is, this is an ether. These are amines, and this is a molecule of ATP, adenosine triphosphate. And adenosine triphosphate is the main mechanism of energy production in the body, where you hydrolyze your 3 phosphate bonds. And when you hydrolyze that, you release 7.3 kcals per mole, and then your body has to recreate this. Okay? All right, so how does all this stuff fit into biochemistry? Okay, so here I gave you a little nugget of a biochemical pathway just to whet your appetite. So what I said about this was ketogenic eating plans are big right now. This is just a nugget of what this might look. Okay, so what happens is you consume a whole bunch of carbons in the diet. Carbon, 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 2, 4. Okay, and your body will chop it up into 2 carbon pieces in a process called beta oxidation, and what you end up with is a whole bunch of these 2 carbon pieces, which are shown right here. Okay? And then this whole pathway then shows you how you end up with ketones, ketone bodies. So ketogenic means that we start with these little pieces, we combine them, here's a ketone here, we end up with these ketones or ketone bodies, and that's why it's called ketogenic. And you probably know or realize that there are some controversies with ketogenic eating plans. So what you want to be able to do is to look at the reactions and don't get overwhelmed by the chemistry of them, but to pick out different parts of what's happening. By the way, This right here is a carboxylic acid. It's just that in solution it's deprotonated. Okay? These are thiols and so forth. Okay? Now, for our purposes, your only job is to recognize basic organic naming, what an alkane is, alkene, alkyne, benzene, and non-carbon only functional groups. What is an alcohol? What is an ether? What is an amine? What is an amide? Etc. Each functional group has its own chemistry, which you can see from here. Its own naming, its own chemistry. That's code for reactions. So that's where you would pick up with an organic or biochemistry course. Now, I'm just going to put in a plug for going the 110, 207, 208 pathway, because a lot of the gaps in this kind of thing are filled by coming to this kind of course, which helps you understand reaction coupling, what the double arrow means, how you couple things together in a way that makes it energetically favorable before you go on to this. Okay? Again, this is a very brief introduction. There are whole courses in this. There's whole PhDs in this. Okay? Now again, those who go out and learn more, there's way, way, way more to the story. Those of you who are done with 110, congratulations for making it this far. Give it your college try and your best. Remember that this Unit 7 will be the organic plus comprehensive naming. Okay? How do you identify something that's ionic? How do you identify something that's simple binary molecular? What's an acid? Okay? So that then leads us to this last sheet. Okay? Ionic. Na plus, NO3 minus. Sodium nitrate. Dinitrogen tetroxide, not ionic, N2O4. H2SO4. It's an acid. The hydrogens are on the left. You had a list. Okay, so that's sulfuric acid. 1, 2, 3, 4 carbons. That's organic. That's butane. This is organic. 3 in the longest chain. Propane. Methyl. 1, 2, 1, 2. Either way you number it, it's still second from the end. Okay? Ammonium carbonate. The dreaded polyatomic ions, remember you have to know those. So I'm going to need 2 of these. NH4, 2, CO3, carbonic acid, that was on the list. And then lastly, 1, 2, 3, 4. Both of these are organic. 1 butene, 2 butene. Okay? These are isomers. These are isomers. These are different. Same, different, or isomers. Okay, go back and review what we did before. Make sure you understand the comprehensive nature of this. Remember, it's just an introduction to organic. And with that, yay! We're done.